Good morning and welcome to our webinar on hanging distribution and fulfillment, the past or the future. The webinar will be presented by Baron DeSantis, who is the Executive Vice President, Partner and member of the Board of Directors of SDI Systems. During his time at SDI, he has been involved in many big distribution and e-commerce integration for SDI. From opening the account to designing, managing the project, and seeing the whole process throughout as account manager. He has participated in implementation of 13 distribution center for JCPenney, Alta Distribution Center for Lululemon in Canada and United States, and among others. Let me remind you that if you have any question during the presentation, you will be able to interact with us through the question tool, and we will be answering your question at the end of the presentations. Baron, the audience, it's all yours.
Hello, good morning. This is Baron DeSantis. Thank you. Hold on a moment. This is Baron DeSantis. Thank you, Santiago, for the lovely introduction, or good afternoon in some parts. I'm here to present to you a presentation, a webinar on hanging distribution and fulfillment, the past or the future. But first, before we went on, I would like to just give you a little introduction of SDI for those of you who do not know of SDI. I'll do a short introduction. SDI, we're warehouse automation providers for all of the worlds of distribution, e-commerce, retail, and wholesale DCs. We're a systems integrator, in-house software developer, and equipment manufacturer. We design, build, and implement these solutions for a continuously evolving client base. And we're considered one of the largest American manufacturers of unit sorters. And for a long time, ever since our inception, we have considered ourselves a one-stop shop for your distribution infrastructure needs, where we go from design to implementation to the full-time maintenance if selected. We're also, among being an integrator, we specialize in unit sortation. And this is just a few of our suite of solutions for unit sortation. We also have a software package called DCMS, which is a full suite of software solutions for the four walls of your warehouse, which include things like WMS, carton sort, item sort, Joey pouch solution, and light directed picking and putting. So all of these software solutions can be selected a la carte for your operational needs. We're a global company. Right now, we just have offices in North and South America, but we do partner with companies in Europe and do work in Europe right now. So we basically do work in North and South America and Europe and spread across those continents. So for the webinar, hanging apparel technology. Before I start this subject, I wanted to ask the group, why would you use hanging systems versus flat systems for your distribution and fulfillment? So you can go to your poll and select the options.
So the question is, why will you use hanging system versus flat system for your distribution fulfillment? To better get to handle my garments? More efficient? Make it better to present to the store or customer? All about them. We left the question for 30 seconds.
Seconds.
Thank you all for your answers. We'll close the questions and
Okay.
share the screen, share the results.
Okay, thank you, Santiago. Just wanted to get an idea of your thoughts on this, if you guys are familiar. So thank you for your answers.
So the answer is to better get to handle my garments 13%, more efficient 80%, makes better to present to the store customer 17%, all of them with 42%.
Okay, thank you, Santiago. So hanging apparel technology. This is a distribution infrastructure and technology that's been around for quite a long time. My father, who's actually a logistics historian on this whole matter, speaks to me about hanging infrastructure being kind of at the beginning of centralized distribution. He started in distribution with a company called Allied Stores back in the 60s, which was kind of one of the first department store retailers among Sears and JCPenney, and said that he was working with hanging distribution infrastructure back then, and it probably went back to the 40s or 50s or even before that. So high level on the high apparel hanging technology that we're going to cover. First would be trolley-based systems, which are mostly manufactured in US and Europe. Individual hanging systems, mostly manufactured in US and Europe. And then shuttle-based systems, pouch and GOH. And all options can be designed based on your operation and design that you elect to go with. Another group question.
Yeah.
Who has some form of hanging systems implemented in their DC/fulfillment center?
We have some troubles, technical troubles, so we pass to another part of the presentation.
Okay, so we'll move on. Apologies for that. This is my first one. So starting with the first chapter would be the trolley-based technology. And within that, there's traditional systems, which are made in USA and Europe, and then the European style. So to start with the traditional systems, I'm sure many of you seen the traditional trolley systems. These are the systems that I spoke about that have been around since, the 30s or 40s or 50s, and have been in centralized distribution for quite some time. And they're still getting implemented. Trolley system JWEBB style. So we call this JWEBB because the track is a JWEBB track that is often used in automotive kind of settings, and then got used to create these hanging systems. With these trolley systems, there is some maintenance on the trolleys and a slight danger to the trolley system, but they're very durable and will last long with proper maintenance and even longer. I have seen a lot of trolley systems that have been out there for 30, 40, 50 years in some distribution centers I go to. So they're very durable. With the switching and stuff, they have pneumatic and electrical switches. They're limited, these systems are limited on flexibility because you can only either divert left or divert right, with limiting flexibility. These systems typically, compared to the other systems, are lower on investment, have a quicker install time compared to the other solutions, but also, once implemented, a little bit more labor intensive. These systems, when transporting, can go at about 60 feet per minute and can incline and decline, and then also can sort by destination with barcodes in front of the trolleys or even RFID in some case. The next would be the European style trolley systems. Some of these features of these European style trolley systems is the trolleys can never fall from the rail, thus being safer. There's a lot more flexibility with these systems, central support, full handling, where you can turn left and right with the switches. The modularity is more robust. Any component can be used for right, left, or triple switch, thus reducing spare parts and allowing system changes with no waste of components. But the price is often a higher investment when it comes to this system versus traditional base trolley systems. Here's a little closer look at the products. As you can see, the flexibility. The switches, you can have three-way switches. You can go different directions. The trolleys, as you can see on the bottom left, are fixed to the track, and then that's an incline-decline component right there. Right there. Also, with the trolleys, you can get a little bit more creative with the way that you design your trolleys, even to the point of creating baskets for flat goods. Like you can see on the left, we have a multi-level basket system that can hold shoes and can be used for things outside of the hanging garments. Also on the right, you can see you can get creative and double up and then create like a hanging and flat kind of carrier system with that trolley. Here's a closer look at this. I'm not sure with the 3D, the movie, it might be coming through or not, but we're just kind of going through a 3D rendering and motion of this trolley that's attached to the track. So next subject, individual hanger technology. And within that, we have polytube and PTP, which is mostly made in the USA, the clip and pin type, made in Europe, and then hang sorters, made in the USA. The polytube trolleyless systems, as you can see, we have some pictures that show you a close-up of these systems with pusher dogs and how they're trolleyless and how they get pushed. Within these polytube systems, you can use pneumatic or electric switches. That pusher dog that's pushing the hangers is a flat-based system that is pushed by the JWEBB in the chain to push the garments forward. There's a high volume of delivery of single garments in excess of 10,000 units per hour on a single line. This is used in a transportation format and not accumulation. So if you're transporting and then you get to a point, your system will stop until it gets cleared and then can move on. You can only divert, you're limited to diverting only left or right based on how the system is designed. This one, like the trolley systems, is limited to about 60 feet per minute and can incline and decline. You can also sort by destination via barcodes or RFID attached to the front of the train of the garments or slug of garments. This also is typically a lower investment, a quicker install as compared to the other solutions, but also a little bit more labor intensive. And you can also automatically feed a shuttle system or hang sorter with the polytube systems. Clip and pin trolleyless systems. As you can see, the left picture is what we call a clip conveyor. That's where you can take the individual garments and you can actually accumulate on that clip conveyor. And then the pin conveyor on the right is used for more of a transportation format. These clip and pin based systems manufactured in Europe, you can accumulate on the system like I just showed. You can merge on a single divert point. You can also have a 2-to-1 merge. You can incline and decline well at steep angles. You can also sort by destination via barcodes or RFID. You can stack trolleys, manual and automatic trolley stacker. It's a safer system than compared to the pusher dog systems and also the trolley systems. This is about a medium investment with about a lead time of 2 to 4 months to get the material. Depending upon where you are, if you're in Europe, of course, the lead time will be shorter. And then if you're in the US ordering these type of systems, it will take a little longer to get over here. The GOH hang sorter. This hang sorter has been around for quite a while now, I think since about the 80s or 90s. GOH hang sorter system, it's the industry standard in high-speed unit distribution of hanging garments. There's design flexibility. You can turn and incline and decline at sharp angles. The sorter can be configured for installation in multi-level or single level operations with equal effectiveness. There's a flexible induction rate, which is associated with the different speeds, and the different speeds are driven by the rope speed and the hook center of the hang sorter. With our hang sorters, if you have the hook centers on 10-inch centers, you can get to up about 10,000 hooks an hour. And if you shorten the centers at about the same speed, 7.5-inch on center of the hooks, you can get up to about 13,000 hooks an hour. Now, that doesn't necessarily mean you're going to be sorting that many units. That's just as many as what we call opportunities an hour to hit the hooks in your operation. Some of the benefits, you can apply it to retail, wholesale, e-commerce applications. Delivery of store to consumer ready products as opposed to flat. No products creasing. Dramatically reduces manual labor cost associated with sortation. Distributed I/O allows simple troubleshooting. Simple machine design results in easy maintenance. There's increased accuracy and decreased processing time with faster delivery to stores or the consumer if it's an e-commerce or fulfillment environment. And now to our group question.
Our next question is, what benefits do you find in your hanging or hanging sortation systems? Flexibility of layout, price maintenance, sort rate, error reduction accuracy, or better presentation to the store customer. Let me remind you that if you have any question during the presentation, you will be able to interact with us through the question tool, and we will be answering your questions at the end of the presentation. Thank you all for your answers. The representation of that word is flexibility of layout 33%, price maintenance 15%, sort rate 58%, error reduction accuracy 58%, and better representation of the store customer 42%. So, Baron, we can continue. The audience is yours.
Okay, thank you, everyone. It's interesting that most people find the benefits being the sort rate and the error reduction rate. Certainly elements that are beneficial with the hang sortation systems. So on to the next one. The next chapter, shuttle-based hanging systems, where within that, we're going to look at pouch systems, where we, SDI, call that the JWEBB pouch solutions, or the trolleyless GOH, which is a form of the JWEBB. The JWEBB pouch solution, as you can see, this is kind of a pouch or bag-based system where you can put merchandise of all sorts inside the bag. Go through some of the benefits. This pouch solution operates at 10,500 pouches through a single chain. And that's basically, again, like the hooks on the hang sorter, where it's basically opportunities an hour. The system can accumulate, sort, and buffer pouches. This solution is very interesting and robust in the sense that it can handle all sorts of merchandise, and you can get up to 100% accuracy, which is very achievable, and I've seen in different operations. Also, you can go based on different gauges of the system, from a light duty to a heavy duty system, which goes from a maximum weight of about 8 to 10 pounds up to 22 pounds if you select the heavy duty option. So this is a very robust system that also saves a lot of cube in your warehouse. Here's an example of one of the layouts, or a very typical way to lay out the JWEBB pouch system. As you can see, you start with an induction, and then you have a primary buffer over at number 2, and then number 3 is a secondary buffer, and then 4 is packing, and then 5 is your empty pouch buffer. The system design parameters, even though we said like that the opportunities an hour would be 10,500, you usually get about 6,000 to 7,000 units an hour with some inefficiencies with induction and packing and stuff like that. If you run the system for about 24 hours, you can get, we've seen where you can get about 120,000 units in a full day with sustainable rates. And usually when you design your packing, your induction, you design it at about 550 units per hour. And then with your packing, design that around 90 units per hour. The trolleyless GOH, which is a new generation. As you can see over here, this is an individual based trolleyless system where right out of receiving, you will associate the barcode or the DNA of the garment and then marry it to the barcode. And you can see the barcodes in the little hangers above where where at receiving you'll associate that garment to that barcode. And then you'll be able to have good tracking of it throughout the whole warehouse. So here's a little video of it, if you can see. So I hope you guys were able to see that video. Here's some closer pictures if you couldn't see the video of the induction and how the garment is married to the barcode. And with the advantage of using this is that you can track and direct the garment all around the distribution as you like. You can direct it to storage, then you can bring it out of storage and then send it to sortation, and then send it down to the shipping door that it's assigned to and it's allocated to. So that concludes all of the technologies of the hanging and apparel technologies that I went over. So I'd just like to open up the forum now to questions, please.
Let me remind you that if you have any questions, you will be able to interact with us through the question tool, and we'll be answering your question at the end of the presentation. Here is a question from Chile. What will buy one system over the other? Meaning, for example, an repair and hanging system over a standard trolley-based hanging system.
Was the question, what would make you decide to buy one system over the other?
Yes, meaning for example, an repair and hanging system over a standard trolley-based hanging system.
Yeah. So obviously, we all design and try and implement these systems to achieve a good or the best ROI. Different ROIs can be driven by different volumes and the design. The trolley-based system would be a cheaper system, a less expensive system, but a little bit more manual. So if you have lower volumes and you're gonna have to take into consideration that'll be a little bit more manual operation, you would look at that ROI in the consulting design process. The European-based system is obviously a lot more slicker and requires less labor but more expensive. So then you would have to look at the ROI based on that system. We also find in Europe that people like the aesthetic a lot better. So then that's one thing with the European system that, you know, gets people interested. But essentially, from my opinion, it would come down to the ROI, and then that would be discovered during the kind of consulting design process before you implement the solution.
Thanks, Baron. Another question from United States. Which one of the systems has better queue optimization of space?
Oh, yes. So that definitely speaks to the European style system or the JWEBB or the pouch solution. With those systems, it's a lot more automated and you can get up above in the air and optimize the cube much better in the warehouse. We've seen examples, and SDI actually did a job recently where there was a lot of space above a cafeteria within a client's warehouse of ours, and we actually put the buffer system over that cafeteria where that space would never have been used before. So therefore, utilizing that space in that cube above was much better handled by using this European style system or pouch system.
Thanks, Baron. We have another question from Colombia. Which industry can use this technology different to apparel?
Well, I think which industry besides apparel? I think that a few of the systems, but not all, can apply to different industries than apparel. Like I showed you before, on some of the European systems, the trolley systems, you can create baskets and you can custom design the carrier to handle other merchandise. So what I've seen personally is for it to handle other kind of flat goods like shoes or accessories and things like that. But obviously you can design these baskets as to accommodate all sorts of merchandise. Also with the pouch solution, that is a very robust solution because you can pretty much put anything in there. You can put toys, you can put shoes, you can put flat goods. And that is an example of a solution that can be applied to other industries besides apparel. So I would mostly say on the European style of systems, those ones can be more customizable and a little bit more flexible to handle other industries and other merchandise of other industries.
Thank you, Baron. So the next question is from Canada. Which system has better throughput?
Which system has better throughput? Did I hear that correctly?
Yes, that is the question.
They're pretty close, actually. You know, the trolley-based system and the GOH sorter, the garment on hanger sorter, you know, like I showed you on the rates, those you can get up to about 10,000 to 13,000 opportunities per hour. Just like with the JWEBB pouch or those other European-based systems can present to the operation and the induction about the same units per hour. It's just when it comes to throughput, the European-based systems are most likely less labor intensive. So when it comes to your actual units per hour, you'll probably get a better units per hour with the European system. But when it comes to actual throughput and pushing through the system in units per hour, they're pretty similar, both systems.
Thank you, Baron. The next question is from Panama. Which are the principal challenges in implementation of hanging system?
One more time.
Which is the principal challenge in implementation of a hanging system?
The challenges, okay, sorry, I didn't hear you. Yeah, the challenges, you know, with, like I said in the presentation before, the kind of standard US-based trolley systems that we've seen have a little bit easier installation time and with less sophisticated parts. And if you're installing in an operation, kind of a greenfield, obviously that's a lot easier than installing around an operation, where both are easily done. The European-based system have more parts and require a more concentrated kind of effort and installation and labor hours to install. So those systems and also lead time. So the planning on the European-based systems requires a little bit more in advance than the standard trolley systems.
Thank you, Baron. We are receiving the final questions. So we are sending a final question about how satisfied we are you with this webinar. Remember, you can send us your question through the question tool. So we are answering you in this part.
So you said are we waiting on more questions, or we're going to wait for?
Yes, we are receiving more questions. So we have a question from Peru.
Okay.
That is, how easy it's to manage different technologies of hanging system at this time?
How easy is it to manage? One more time.
Different technologies of hanging system at the same time.
Diego, your mic is a little off. Say that again.
Okay, the question is, how easy it's to manage different technologies of hanging system at the same time?
Different technologies. Well, that depends on how far you go into the implementation or the integration. So as you saw in the presentation, there are examples of static systems. So let's say you had a static system of the standard US trolley based and then the European based. You would have a bit of a conflict between the trolleys and so forth, and the different. So you couldn't take a trolley from a standard US trolley based and transport it and connect it onto a European based. So they basically would be separate systems. So in that sense, if you were to mix technologies, you would have a conflict in the mechanization of the systems. Also, software and controls wise would be a little different. Let's say you had another provider in there and then used another provider to implement a system, then you would have a conflict between the controls and stuff. But basically the advice and the bottom line is to stick with one system or migrate over into another system if you're interested in another technology.
Okay, thanks, Baron. The last question. What is your opinion on the future of these technologies?
So, like I said, hanging, it's funny, as I've been in logistics for about 20 years, I saw hanging kind of on a good pace and everything, and then it went more flat. And then it seems like there's been a little bit of a resurgence. So to answer the kind of question of the title of this webinar is it dead or alive? It's still going, maybe not as strong as it was before. And the way that I see it is people are starting to adopt and want and desire for more of a sophisticated technology, which is like some of the technologies in the more European style that I've shown you. So those styles have been in Europe and are in Europe and getting implemented for a while now. And now what I'm seeing is the US adopting and getting interested in the kind of more sophisticated technology when it comes to the hanging systems. And they're still getting implemented. Our partner company in Italy has just started up about 4 or 5 years ago, and he's purely hanging, and he's doing quite well right now. We at SDI are still working with our clients or new clients that want hanging technology implemented. So it's still around, and I think here to stay for a bit.
Thank you, Baron. And thanks everyone for joining us in this webinar. And we see you in the next webinar.
Okay, thank you everyone for your time. I appreciate it. Sign off.